This is Learning Assessment Problem 914. The problem-solving strategy will be the calculation of the effective or root mean square value of a periodic waveform. In this problem, we are requested to determine the RMS value of this voltage waveform, which is comprised of triangular pulses. The basic period of this waveform occurs between 0 and 4 seconds. The procedure for determining the effective or root mean square value of this voltage waveform will be as follows. First, we'll form the square of the voltage waveform. Then we'll integrate that over one period. And we'll average the result of that integration by dividing by the length of the period. And finally, we take the square root of that result. In the current situation, our voltage waveform has two components. In the period from 0 less than t less than 2 seconds, v of t is of the form mt, where m is the slope, the waveform passing through the origin at time 0. So we can determine the value of m by saying that at 2 seconds, v of 2 seconds is equal to 4 volts, and that's equal to m times 2 seconds, or we have that m is equal to 2 volts per second. So over this interval 0 less than t less than 2 seconds, v of t is equal to 2t volts. Then over the interval from 2 seconds to 4 seconds, the remainder of the period, v of t, is the simple result, 0 volts. Now our calculation for the RMS value of this voltage becomes, we've integrated the 2t quantity for our triangular voltage pulse over the period 0 to 2 seconds. And then the remainder of the period, we just have 0 for the amplitude of the voltage, and that part simply becomes a 0 for the result of that integration. Or VRMS becomes the result of integrating t squared. We obtain t cubed over 3. 4 quantities canceled here, and we evaluate this expression between the limits 0 to 2 seconds. And this is equal to the square root of 8/3 volt, or 1.633 volts.